Trigonometry revolves around angles. So we're going to start our discussion by looking at different ways that angles are measured. And in the process, we'll add a few new definitions and make some connections back to ideas from geometry. Now in trigonometry, a lot of our work is going to be done here in a coordinate plane, and we have a standard way that we're going to draw our angles on it. The vertex of the angle always goes on the origin, and the first side, called the initial side, always goes along the positive x-axis. Now the second side, called the terminal side, is drawn wherever you need it to be for the size of your angle. So this is the terminal side. Okay, to measure angles, we're going to use two main systems. The first one is the standard degree measure that you're used to from high school geometry. We take the entire circle, divide it evenly into 360 pieces, and each one is a degree. So that makes a quarter circle 90 degrees. A half circle is 180 degrees, and so forth. Now, in geometry classes, angles are usually limited to being between 0 and 180 degrees. Now, for our purposes, there aren't going to be any limits on an angle side. For example, this angle, drawn counterclockwise, is 235 degrees. Now, when we're talking about things that are rotating, we need to be able to talk about things that are spinning clockwise as well as counterclockwise. And we're going to do that in the obvious way, by letting angles drawn in that direction have a negative measure. So if this angle is 235 degrees, the same angle, but going from the initial side to the terminal side in the opposite direction, would be negative 135 degrees. And this is similar to what you saw back in Algebra 1, right, with number lines. If you started at 0 and went to the right, you'd end up on a positive value, where if you went to the left, you would end up on a negative value. Now, two angles, like this pair, that have the same terminal side, but different measures, are called coterminal angles. Okay, so decimal degrees, they work for a lot of things, but they do have some disadvantages. For example, it takes a lot of degrees, 360 of them, just to get a full circle. And that's going to be a big disadvantage when we talk about graphing, looking ahead in Chapter 4. Now, also the size of a whole circle, it's 360 degrees, which is a pretty arbitrary number. So the radian system that we're going to talk about here addresses both of those issues. So to see how radians are defined, take a look at the diagram here. It starts with a circle whose radius is r, and an angle whose measure we'll call theta, using the Greek letter. Now notice how the angle cuts off a section of the circle, right? If the length of that arc is s, then we'll define the radian measure of the angle as the arc length cut off by the angle divided by the radius of the circle. Okay, so to get a feel for this new unit, let's take a look at some specific angles and see what their measures come out to. So if our circle has a radius of r, then s, when we're talking about a full circle, is the total distance around. That is, it's the whole circumference, which is 2 pi r. So if we divide the arc length, 2 pi r, by, excuse me, getting a little messy there, by r, we get 2 pi. Right? That's the number of radians. That's the radian measure of a full circle. Now, a half circle has an arc length of half the circumference. That's pi r. And if we divide that by r, we get a radian measure of pi radians, which makes sense. Right? This is half of a full circle, so I expected the size of the angle to be half the size of the angle that we got from a full circle. All right, so again, using the same reasoning, a quarter circle will be a half of a circle, or pi over 2, and 3/4 of a circle will be 3 pi over 2. Now, if you look carefully at the columns in the table here, you'll see that I didn't put any kind of units. I didn't put, for example, the little degree symbol that we use to denote the degree measure. Sometimes you'll see RAD used to indicate a value that's in radians. However, it's most common to put no units after a radian measure. For example, just 2 pi, pi over 2, just like I have them here. So as a general rule, if there's no unit after an angle measure, you should assume that the value is in radians. So now that we have our new angle measure and some idea of what its values are going to look like, we need a way to convert back and forth between degrees and radians. And the half circle value here gives us an easy conversion factor that we can use. 180 degrees is equivalent to pi radians. All right, so let's use that. Right, let's use that conversion factor to take each of these measures and convert them to the other system. And to do this, I'm going to use the pi radians over 180 degrees factor. So with 45 degrees times pi radians divided by 180 degrees is equal to pi over 4 radians. And notice how I left pi in the result. Okay, that's not unusual when we're working with radians. They're often given as a fraction of pi. Okay, so how about 2.6? There's no degree symbol here. There's no units indicated. So I'm going to infer that that's a radian measure. And to do this conversion, I'm going to use the conversion factor the other way around. Right? So 2.6 radians times 180 degrees per pi radians is equal to, you get your calculator out for this one, right? This is 148.97 degrees. Okay, now in this case, I didn't leave pi in the answer because degree measures are always given as decimal numbers. All right, so how about this next one, 143 degrees? Well, I'm going to use that same pi over 180 factor, 143 degrees times pi over 180 degrees. And 143 divided by 180, you really can't reduce that fraction any. It doesn't come out to a nice fraction, like a half or 2/3, right? So in this case, I would just go ahead and get my calculator out and do the decimal version. This is 2.50 radians. Okay, so for this one, 2 pi over 3, we could use the conversion factor, but there's a really quick shorthand that I use when the radian value has pi in the numerator. Just replace the pi with 180, right? That makes this 2 pi, this makes this 2 times 180 divided by 3, which is 120 degrees. Right now, when you use this shortcut, it's important that you only do it when the pi is in the numerator of the fraction. It works because if I had multiplied by the 180 over pi conversion factor, the pi in the numerator of the angle measure would cancel with the pi in the denominator of the conversion factor. If you have a pi in the denominator, which would be weird, but okay, if it happens, for example, if you have something like 3 over pi, okay, then you have to multiply by the conversion factor like I did in the 2.6 radian example. All right, so in the next lecture, we're going to take a look at our second new system of measurement. It's a little archaic, to be honest, at this point in time, but it does still get used, in particular in astronomy where time is an important consideration.